Find the exact values of the trigonometric functions of pi over 4 radians, 45 degrees, 30 degrees and 60 degrees. Let's draw a right triangle with 45 degrees angle. So straight. So we have a right triangle, so 90 degrees, and this angle is 45 degrees now, or pi over 4 radians. Okay, then this angle should be also 45 because the sum of all three angles is 180, so it's 90. So the sum of these two angles should be 90 as well, so this is also 45. That means these two sides should be equal because these two angles are the same. So for simplicity, if we take this side as just say a, but let's take even easier 1, then this is also 1. As we know, this is adjacent A, opposite B, and hypotenuse C. So this is 1, the length of this is also 1. Now we need to find the length of C. For that we use the Pythagorean Theorem, which is a squared plus b squared equals c squared. A is 1 is square 1, b is 1 is square 1, and c is unknown. 1 plus 1 2 equals c squared. Now take square root both sides, so c equals root 2. So this unknown side is root 2. In fact, we could have taken this side as x, and this would be x as well, and we would get root 2 times x. Same thing. Now we're going to find the exact values of these 6 trigonometric functions. So sine of 45 degrees, as we know, the ka toa. So sine is opposite over hypotenuse, so opposite over hypotenuse, b over c. So sine 45 degrees is 1 over root 2. But generally we don't write a square root on the bottom, so this is same as 1 over root 2 times we multiply top and bottom by root 2 over root 2 to rationalize the denominator. That makes root 2 times 1 root 2 on the top, root 2 times root 2 root 4, which is 2. So root 2 over 2. Or in some books they also leave 1 over root 2. That is also true. Let's go for the second, cosine 45 degrees. So ka toa, ka adjacent over hypotenuse, so 1 over root 2 again, which is same as if we rationalize the denominator, we get root 2 over 2. Then let's find tangent 45 degrees, toa, opposite over adjacent, 1 over 1, which is just 1. And we can find the reciprocal of sine, which is cosecant of 45. We had 1 over root 2, now we can use this or we can use this, doesn't matter. 1 over root 2, its reciprocal is root 2 over 1, so just root 2. Similarly for secant 45, secant is the reciprocal of cosine. Let me use 1 over root 2, then when I flip, find the reciprocal, it is just root 2. And cotangent of 45 is the reciprocal of 1. 1 is 1 over 1, just 1. Okay, this is how we find all trigonometric function values of 45 degrees. Okay, let's do same thing for 30 degrees and 60 degrees as well. So I want to draw a right triangle with the base angle of 30 degrees. Let's go for that. So right triangle, (90 degrees) and smaller angle 30 degrees. Okay, then sum of these three angles is 180. This is already 90, so 30, so this should be 60. Okay, this is 60 degrees. For this angle when we refer to 30 degrees, then this is adjacent A, and this is opposite B, and this is hypotenuse C. Here we don't know anything about two sides because the angles are different, so we cannot do unlike the previous. But how about this is 30, this is 60. If I add 30 here, okay, 30 degrees, and straight, just go straight this, adding 30 more, so this is 60. If we look at the bigger triangle, this is 60, this is 60 now, then this will be 60 as well, because 60 plus 60 plus 60 is 180. Okay, so we get an equilateral triangle. Okay, all sides equal. Then if we take C equals, let's say, just take 1 for simplicity. Okay, then this side we don't need that. This will be also 1, and the whole thing will be also 1, because this is an equilateral triangle. 1, whole thing 1, so this will be just half. So B will be up to here. This is 1/2. Now we need to find this side A. From Pythagorean theorem, we know that a square plus b square equals c square. From that, we will be able to find the value of a. Okay, in this way, let's do it. A square plus b square equals c square, where a is unknown, plus a plus b. B is 1/2 square, and c square 1 is square 1. A square plus 1/2 square is 1/4 equals 1. Subtract 1/4 from both sides. A square equals 1 minus 1/4, 3/4. Take a square root, so a is square root of 3/4. Square root of 3 on the top, and square root of 4 is 2. So this side a is in fact root 3/2. So we don't need this extended triangle anymore. So let me erase that so that we can see better. Okay. So we have this a adjacent to 30 is root 3/2. So this is root 3/2. Now since we have all three sides, we can find sine 30. Reciprocal of sine is cosecant 30, cosine 30, secant 30, tangent 30, cotangent 30, and sine is just opposite over hypotenuse, so 1/2 over 1, which is 1/2, and the reciprocal of 1/2 is just 2. Cosine is adjacent over hypotenuse, so root 3/2 divided by 1 is just root 3/2. Secant is reciprocal of this, so 2 over root 3. You can rationalize this, but that's not really necessary. Tangent is now b over a, so 1/2 divided by root 3/2. Let me do over here, 1/2 divided by root 3/2, which is 1/2 times, flip this, 2 over root 3. Cancel, so we get 1 over root 3. Or we can rationalize this, because sine, cosine, tangent values are used most of the time. So I want to rationalize this. So 1 over root 3 multiplied by root 3 over root 3. Then root 3 times 1, root 3 on the top. Root 3 times root 3 is root 9, which is 3 on the bottom. So tangent 30 is root 3 over 3. Now cotangent 30 would be then this, the reciprocal, or we can use this 1 over root 3, same thing, and reciprocal of 1 over root 3 is just root 3. Okay, this is how we find all the sine, cosine values, all trigonometric values for 30 degrees. From the same triangle, now if we think 60 is the base angle, then we can find all 6 trigonometric functions for 60 degrees. So let's do that. So let me erase this. And these values later will be revealed using a unit circle. Okay, so you will have two options to know, learn, memorize these values. So let me use the same color, red color, for 60. So if we are considering 60 as the reference angle, then this will be adjacent. So this 1/2 is adjacent to 60. This is opposite to 30, but we are about to consider sine 60, cosine 60, tangent 60, their reciprocals, cosecant 60, secant 60, cotangent 60 values. Okay, 60 degrees by the way. And for 60, this is adjacent, this is opposite, so this will be B, and the hypotenuse remains the same. So sine is now SOHCAHTOA, opposite over hypotenuse. For 60, this is opposite, so √3/2 divided by 1/2. Oh, √3/2 divided by 1/2, what is what? Let me find that. √3/2 divided by 1/2. This division into multiplication, then this to cancel. √3/1 is just √3. Oh, made a mistake. Sine is opposite over hypotenuse. That's a mistake, what I said earlier. This is a mistake. Opposite over hypotenuse. So √3/2 divided by 1. Okay. Sine is, look at this, SOHCAHTOA, opposite over hypotenuse. For 60, this is opposite, hypotenuse remains the same. So √3/2 divided by 1, just √3/2. So cosecant is just flip this fraction, 2/√3. You can rationalize, but that's not needed. Cosine 60, cosine is adjacent over hypotenuse. For 60, adjacent is 1/2 divided by 1, just 1/2. So reciprocal of 1/2 is 2. Now tangent 60 is now TOA, opposite over adjacent, opposite over adjacent. Yeah, that's what I was doing earlier. √3/2 divided by 1/2, 2 cancel, √3/1, just √3. Tangent 60 is √3. √3 means √3/1, so cotangent 60 is 1/√3, or you can rationalize if you like. Okay, final